Once the desired position has been achieved, it's secured by turning a locking knob. As the actuator is moved to the desired position, the software provides easy guidelines to let the operator know when the correct position is achieved. We then release the spray. The spray is collected by the extraction device. The Malvern Spraytec may be fitted with an inhalation cell for measurement of inhalation aerosols. By pulling a vacuum from below, it's possible to maintain a constant flow rate through the measurement zone. The flow rate can be set so that it equals the flow rate needed to validate measurements from a cascade impactor. However, the Spraytec does not require a constant flow rate. The flow may be reversed to mimic breathing. The inhalation cell may be used in a vertical position to measure metered dose and dry powder inhalers through an induction port. Nebulizers are measured directly through the cell in a horizontal position. To introduce the inhalation cell to the Spraytec, we need 2 adapters for the optical units. Each adapter has an inner gasket to ensure a tight fit against the optical unit. Transforming the Spraytec from an open configuration to the inhalation cell is easy. First, the cover caps are removed from the optical units to make room for the adapters. Then the 2 adapters are mounted to the transmitter and receiver units by fastening them with 4 small socket cap screws. Now the Spraytec is ready to receive the inhalation cell. The first step is to mount the inhalation cell to the X95 rail. This is done quickly by positioning the inhalation cell on the X95 rail and then fastening the 2 finger screws at the bottom plate of the inhalation cell. Then the 2 optical units are released to slide along the X95 rail. This is done by loosening up the 2 finger screws at the base of each unit. The units are then pressed firmly against the secured inhalation cell. The holes in the adapters accept the geometry of the inhalation cell with a sealed and tight fit. The finger screws at the base of the optical units are tightened, and the system is ready for measurements. Having turned the inhalation cell to a horizontal position, nebulizers may now be measured across the laser beam. A small adapter is mounted to the inhalation cell entry port, and a pressure nebulizer may be mounted to the cell. Data is now collected in continuous mode, in which the detector is read at 1 Hz frequency. In this mode, the data is shown real-time on the monitor as the measurement progresses. The top line is the transmission, followed by DV90, DV50, and finally DV10. The data display with the x-axis being the timescale is referred to as the time history profile. Data segments from the time history profile may be averaged and displayed as an averaged size distribution. Size distributions from aerosol cans are easily characterized using the Malvern Spraytec. An aerosol positioning device helps mounting the can and holding it in a fixed position with respect to distance from the nozzle to the laser beam and distance from the nozzle to the detector of the Spraytec. The holder will accommodate different can designs. The right height may be chosen by moving the nozzle into contact with the laser beam and then backing off to the desired distance, at which point the position is secured with a locking knob. We can now actuate our aerosol. The red flare indicates the interaction of the laser light with the aerosol as the latter travels toward the extraction source. To run the experiment, we choose an SOP and a file to store the data. As the SOP progresses, the operator is allowed to enter information about the sample. The software then instructs the instrument to measure a dark background. It automatically aligns itself and takes a light background. Both background signals are later subtracted from the actual detector readings received from the aerosol. The data is collected at 1000 Hz over 2 seconds. By using a transmission trigger, the instrument holds back data collection until the trigger condition is met. Once the aerosol data has been actuated and data streamed from the instrument board to the computer, the software screen gets updated. An average may be performed automatically, provided the time interval for the average has been specified in the SOP. The collected data may be viewed in table form or in graph form. Besides the standard parameters, 16 custom parameters may be monitored as well. The data from the Spraytec is also shown in a time history display in which the x-axis is a time scale. The horizontal lines from top to bottom are respectively transmission, DV90, DV50, and DV10. This display is useful in understanding the dynamics of the spray event to see if anything unexpected occurred during the actuation. A holder helps to maintain a small nozzle at a fixed position. The nozzle is fired up, and across the beam an extraction source receives the product. To run the measurement, simply start the SOP. This is a file that instructs the instrument to run the sample in a consistent manner. A file is picked to store the data. As the SOP progresses, the operator is optionally allowed to enter information on the sample being run. The software then instructs the instrument to measure a dark background. It automatically aligns itself and takes a light background. Both background signals are later subtracted from the actual detector readings received from the aerosol. Data is now collected in continuous mode, in which the detector is read at 1 Hz frequency. In this mode, the data is shown real-time on the monitor as the measurement progresses. The top line is the transmission, followed by DV90, DV50, and finally DV10. The data display with the x-axis being the timescale is referred to as the time history profile. The pressure is increased, and we can instantaneously see how the size parameters are going down on the time history profile. Data averages are now easily created and overlaid for comparison of the 2 different pressure settings. The overlaid data may be displayed as either cumulative % finer than or as frequency distributions.